Okay, so here we are. Welcome back. This is what we're doing today. We are working on our quiz 10.1, 10.2. We're going to review that a bit, and then we're going to do 11.1 goodness of fit test. I would like to try to get to showing you guys a little bit about Project Lab 10 if I can. I don't know if we'll have a chance to do that, but we'll try. And then today you have due Connect Math 10.1, and also Project Lab 5 is due tonight. Just email that to me by midnight. It's late, but still full credit if you email it by tonight. Thursday you have Connect Math 10.2 due, and then next Tuesday you have 11.1 and also Project Lab 10. That'll be its official due date, but you can turn in late for full credit after that. The final, again, a reminder, is going to be 35% of it is going to be on this Exam 4 stuff, Chapters 10 and 11, because Exam 4 is rolled into the final, so it makes that a lot higher. The rest is going to be about 20%, 20%, and 25%. Okay. So, yes? The lab is 7% of your grade?
Okay, thank you.
Yeah. All right, so quick reminder, correlation determines if there is a relationship between two variables, and regression is whether it's a positive or negative relationship or whether it's linear or nonlinear. And this is kind of what we're doing in this chapter. We are kind of looking at these 4 questions. Are 2 or more variables related? If so, how strongly are they related? Oh, that's why I had this R. That was R. So R, it's not a very good R. So yeah, so R is sort of we can kind of see how closely they're related from R, and then what type of relationship exists, and if we can predict from that. Right, so if there's a strong relationship, if R is very close to 1 or negative 1, then we say, oh, it is a line, and then we can use that line to predict. Scatter plot. So this is a graph of the ordered pairs, right? You're going to make your X and Y axis. The X axis is the one that's independent that you can control somewhat. And then your Y axis should start at 0. Occasionally you'll see this thing where there's a little squiggly line in between, and that's when they really can't realistically start Y at 0 because it's hard to see the data well. So then they put the squiggly line to let you know that we started at 0, but then we had this big jump in between, and then we resumed at these higher numbers up here to kind of give you a heads up. So then it's not quite as misleading because you can kind of see that there's something going on there. So this should be, oops, I guess I took a picture of yours. I guess not. Yeah. Oh, really? Well, that's... Okay, let's try this again. Oh, I know what I did. Maybe? Okay, let's try this again. Thank you. There. Is that better? Yes? Yeah. Okay, great. I'm so sorry. Thank you. So yes. So again, here are the things that are due. Connect Math 10.1 due today, along with Project Lab 5. 10.2 is due on Thursday, and then 11.1 and Project Lab 10 are due on next Tuesday. And then also your final information. Great. So, moving on. We talked about correlation regression. I talked about that. I don't need to talk about it again. And we talked about those questions as well. Not a big deal. All right, so again, scatter plot. This little squiggly line here is kind of what some people do sometimes, because Y always has to start at 0, the Y axis, in order to keep it from being a misleading graph. But sometimes people it's so unrealistic to show that, so they put this little squiggly line just so people know. It usually looks something more like, honestly, it looks more like kind of like this. kind of just, it's a little jagged line that kind of looks like that, sort of, in a way. And that's just kind of let you know that we've done something in here. It started here, but then we kind of jumped a bunch, and then we continued on up here. I don't have, can someone share their screen and show, actually no, we'll go ahead. We're going to proceed. Okay, great. So the next thing we want to talk about is remembering that row. This is that weird P looking like thing. It's not a P, it's just a kind of a loopy thing. It kind of just goes up and around, right? It's just a sort of up and around sort of thing. It's not a P. A P would look like this, with a little tail there, with a little point up here and stuff like that. So it's not that. It's a rho, just this little loop around. It's a Greek letter, RHO. That's the population correlation coefficient. The sample correlation coefficient is just R, and that's one we're going to be using mostly. And then we'll be comparing using the PPMC table for our critical value. So we're going to compare R to our critical value from the PPMC table. And then the range of correlation is from -1 to +1. So if there's a strong positive correlation, in other words, it makes a total line, right, total positive line, then it's going to be right around +1. If there's a strong negative correlation, in other words, it makes kind of this solid sort of negative line going, straight line going with a negative slope, then it's going to have a correlation coefficient closer to -1. That's the perfect line. And it's kind of nice because if you look at these symbols, they sort of look like, this looks like this one looks like, if you kind of tilt your head a little bit, this sort of looks like a 1. If you tilt your head the other way, then this other one over here looks kind of like a 1 as well. So, that kind of helps. And then the 0 in the middle, no linear correlation. That looks kind of like, like a ball, just a bunch of dots that kind of make up this sort of round sort of ball in a sense. So that also, I think, is sort of kind of helpful because visually they sort of match up with what they should kind of be. All right, so next, you guys have, put this down here, one to do yourselves. This is going to be something that's going to be on your exam. It will be on the final. So take a look at it, and I would like for you guys to take 15, 20 seconds by yourselves, maybe 30 seconds, and then jump in with your group and confer with your group. I'm going to give you guys 2 minutes on this. 1 minute, 40 seconds on your own, and then jump in with your group to decide which numbers go where. Which one, private chat me, which one is 100? So in the private chat, don't say it out loud, just in the private chat, indicate which one. Why is my private chat not coming up? I don't understand why my private chat isn't coming up. Okay, there we go. Which one's 100? Seven, 8, 9 people, 10 people. Okay. About half of you got it right. About half of you, actually a little more than half of you guys got it right. None of them. Correlation coefficient only goes from 0 to 1. Sorry, from 1 to -1. So it's impossible to have a correlation coefficient of 100 or 50 or 5 or 2 or -100, -50, 5, -2. You can't have that. It's impossible. That's like having, it's like saying what percent of people pass got an A, 112%. That's not possible. Or negative 2%. That's not possible because it's not a possibility. So, in light of that, which one is, so hopefully you guys, well, I'll show you guys. Hopefully this is what you guys should have. Right, this one's 1, 0. This one's negative 1, and then this one here is closer to a line than this one. These are the two positives. So since it's more like a line, then it's closer to 1 than this one. So point A is closer to 1 than point 6. So that's why that's like that. Oops, I'm going to undo this. And then on the bottom, the same idea. This one down here is closer to negative 1 because it's more like a line than this one is. Okay. All right. The other thing about R that we're going to take a look at is how to find it. Right? So it should be between negative 1 and positive 1. Incidentally, this will be on your exam, something like this. Right? So, and it should be the easiest 3 or 4 points you should get on the exam. So make sure you understand that and know that. All right. Here, our sample correlation coefficient R, there's this big long formula used to compute it. Luckily, you guys can now use, I'm going to let you guys use your TI calculators and just use stat test Lin-Reg t-test to calculate it. Just putting your x's into list 1, your y's into list 2, and then just do stat test Lin-Reg t-test. And I'll show you what that looks like. Maybe. It's thinking. Well, that's not super useful. There we go. Yeah. Oh. Okay. Yeah. Oh. Interesting. I wonder what the other options are. Let's take a look. We'll try that. Thanks for pointing that out. Let's try it. So here I'm going to go stat edit. I've got some data in there. It doesn't really matter what my data is. And then I'm going to do stat. So for you guys, again, you're going to put your x's into list 1 and your y's into list 2. And then you're going to do stat test and then arrow up. Because Lin-Reg t-test it's at the bottom, so it's easier to get there by going up. Not interval. This is a test. Lin-Reg t-test. Hit enter, and then your your x's are on list 1, your y's are on list 2. Leave your frequency at 1, and remember, we're always going to be testing to be not equal to. So it's always going to be not equal to here. And then I don't know what we would put there. What would they want you to put? I don't know, but we'll leave it blank. You said it stood for say it again, Jay? It stands for linear regression.
Yeah.
The Reg EQ.
I don't know about that.
Oh. Right. Yes, linear regression t-test. Right. I don't know what the Reg EQ is though. I have no idea what that means. So I just leave that one. Leave it blank. And then hit calculate. And yeah, so you guys should remember this Lin-Reg should make sense because linear regression, that's what we're doing. And then y equals a plus bx. A is 20. You should keep note of that. Whatever. It might be a 0 in this case. And my r is, it's because I had to straighten my mic. But it'll give you your r. So for your data, it should give you your a, your b, and your r, which are all things that you're going to need. I had garbage data in there, which didn't, result in anything useful. But that's how you find your R. That's how we calculate R.
And we have the beta also.
Yes. So the p-value is there also. So this tells you it should be between 0 and 1. My data was all straight lines, so it was weird, but and that tells you the probability. So that also gives you that as well. Okay. So here's a better one. Right. So here you can see, here the R, here's the R here, negative 0.428 in this case, and here's the B, so it should look something more like that. All right, hypothesis testing, we have our 5 steps. The first step is this one right here. So our first step is our H naught, which is rho is equal to 0. That's always going to be the case for chapter 10. H naught is always, always, always no or not. In this case, no line, no correlation. That's what the H naught means. So you guys pay attention, because this is one that people totally screw up, and I promise you, you guys are going to be confused about this later on, some of you. So H naught is always, always no. No difference equals, right? No difference is equals. No correlation, no line. That's what it is, all these no's. Which means that if it's true, then we would not reject H naught, in which case it would not be a line. So if we do not reject H naught, then it's not a line. You'll kind of see that later on. And then H1 is that rho is not equal to 0. In other words, there is a significant correlation. There is a line. So if I reject H naught, which means that I like H1, that means that it is a line. Yeah. I am.
Okay, thank you.
You're welcome. Yes.
Which one of these is our claim?
So for chapter 10, we're going to kind of say, we're going to get away from claims at all. We're going to ignore claims altogether.
So when I had done the homework, it makes you pick the claim.
Oh, typically H naught is the claim. Oh wait, typically H1 is the claim, I think, with these ones. I think usually H1 is the claim. Yeah, and I think it's usually that you're saying that there is a correlation. So typically it'll be H1 would be your claim, and for chapter 11, typically H naught will be your claim. So we'll talk about that. So you're saying, so my guess is that typically the claim would be, because usually you wouldn't say, well, these two things aren't correlated. That's what I'm guessing. Usually you'll say, well, I think these two things are correlated. That's kind of a more typical claim. You want to know if two things are related or correlated. So typically H1 will be your claim. Thanks. Good question. And then step 2 is, again, using the PPMC table and finding your critical value. So you'll look it up using degrees of freedom of n minus 1. So say I have 7 items, then my n minus 1 would be, n minus 2 would be 5, so then my degrees of freedom would be 5. So degrees of freedom n minus 2, I'd be looking at the 5s. If my alpha was 0.05, then I'd grab this guy right there. So then I'd say, okay, well, my critical value is 0.754, so I'm going to make a little line up here, straight up top. If you look at the top up here, make a line. So it's like you're drawing only, it's like normal only without the hill. So instead of a hill, it's going to be just a straight line, and you're going to put in your critical value and shade off to the right. So 0.754 shade to the right, and then negative, because remember these are always going to be left-right tails in chapter 10, negative 0.754, and then shade off to the left. And then remember, these very endpoints are 1 and negative 1. So these spots that are furthest out, why am I not getting able to grab anything? Are this one over here is negative 1, and this one over here is positive 1. Because that would be, positive 1 would be a perfect line with a positive slope, and a negative 1 would be a perfect line with a negative slope. Oops. Oh, no. No, don't die on me. Oh, that could be really bad. Okay. Maybe I should save this before it dies. All right. So here was your problem you had on your quiz, and this is somewhat what your scatter plot should look like, more or less. you notice there's an amount down here at the bottom, and then the x's went from 1 to 7, not percents, because these are all assuming they're percents. So your x values are 1 to 7. And then the reaction time is here along the side. Typically time will always be on the bottom, but this is reaction time, so it's reaction time, not just regular time. So that's why it's on the left. But your scatter plot should look something sort of like that, more or less. And let's go ahead and take a look through this. So here are H0 is rho equals 0. H1 again is always rho is not equal to 0. That always changes. That's always the same. For chapter 10, this will always be your H0 and your H1, always. My critical value, I'm going to pop that, let's see, let's take a look. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 items. So 12 minus 2 is 10. Degrees of freedom is 10. My alpha is 0.05. So 0.576. That's my critical value. So if I kind of look down here, you'll see that's my critical value there. And I'm going to save this before bad things happen. So I drew my little line, and then shaded out. I put 0.576 here and shaded off to the right. Negative 0.576 here and shaded off to the left. So you can see that there. And then step 3. So Lin-Reg t-test, you're going to put all of your data, your x's into list 1, and your y's into list 2. And then you're going to do stat test Lin-Reg t-test at L1, L2. So hopefully that's what you guys got and what you did. Let me put this in there. And then what you ended up getting was an R of 0.941. So then we threw it in here. It goes, 0.941 is between 0.576 and 1, so it goes in there, which is totally in the rejection region, right? You can see that. So we're going to reject H0, which means, so since I do reject H0, then it is a line. Make sure you kind of get used to writing that down, because this is kind of what's going to keep you on the right path. Rejecting H0, you do reject H0, then you do have a line. If you do not reject H0, then it's not a line. But here, since you do reject H0, then it is a line. Uh-huh. I want the enough evidence, but I would like you to do both, because this is a line part will totally help you with everything else. It will make your life easier. So this will help you with this next part down here. So then you would say, since I reject H0, I do have enough evidence, right? There's enough evidence to, and then you can always just state this part, to say there is a correlation between blank and blank, whatever your x and y are. So this is all you need to say. Blank evidence to say there is a correlation between x and y. That's all you have to say. And it's either going to be not enough evidence or enough evidence. There's no sort of, I'm not going to worry about the claim there. So, but what Angel said is on the homework, there might be a spot where they ask for the claim, and the claim would almost always be H1. I can't imagine, it'd be very weird for it to be H0. So, but yes.
I think it marked it wrong when I said the claim was H1.
Okay, well, can you take a snapshot of it and email it to me or something like that? Or tell me what problem it was, and I can take a look at it later.
It was like
And you used H1?
yeah.
So it should almost always be H1. If it says it's wrong, then pick a different version. Pick it, do it, try it again, because it should. It's very, very rare it should ever be H naught. Almost always, you're looking to see if you want to see if there's a relationship or correlation between two. If they say, if your claim is that they're not correlated, then your claim would be H naught, right? Because this would be not correlated. And this would be, H1 is correlated, is aligned. So if your claim is correlated, then it should be H1. If your claim is that there's no correlation, then it would be H naught. But that just seems weird. And I'm not going to test you on that. It's just the homework. You have to worry about that. Okay, and the last part, your line, your regression line is going to be y equals a plus bx. You pull those numbers straight from your Lin-Reg t-test. So your Lin-Reg t-test gave an a of 0.0193 and a b of 0.6371. 3 sig figs is, you need to have at least 3 sig figs. 4 is good, but this is fine like this. So this is your linear regression line. You cannot always use your linear regression line. You can only use your linear regression line when, in step 5, you found that it is a line. Because if it is a line, then that means that this line here is valid. If it's not a line, then this line here would be total garbage. Do you guys see what I'm saying? So you have to check and see if it is a line, then yeah, we can use this. That totally makes sense. So that's great. It is a line, so we're going to use it. And we are given 5.2%. So is percent my x's or my y's? It was my x's, right? So in this case, so x would be 5.2. Don't do 0.052 because that, it's the percent is just a label. All of them are in percent. All of your x's are already percent. So that percent is just a label in this case. On the exam, it will not be like that. On the exam, it will be much more straightforward. I won't do any weird things like that. Don't worry about that. Just the examples like that. So put 5.2 in there for x, because this is my x value, right? Percent was my x's, so it means that when my x is 5.2, what's my y? So I'm going to put in 5.2 for x to figure out what my y is. So I'm going to put that in for x, and I'm going to get y is 3.33 seconds when x is 5.2. So when I get 5.2% of drug, then my reaction time is 3.33 seconds. Okay. There's the Lin-Reg t-test. And then here is the problem number 2. Do you guys need just a few more minutes to go over that one? Do you guys need 2 more minutes, or is it already good? I'll tell you what, let's do this. Once you guys work on this one, and let's make sure you guys are okay so far. So your H naught also is always going to be rho equals 0. H1 is always going to be rho is not equal to 0. And then your critical value should be from from that table, PPMC table. So I have 1, 2, 3, 4, 5, 6, 7 items. My degrees of freedom is 5. Alpha is 0.1. It's a little bit different. I wonder if I was smart enough and did this. Yes. So alpha is 0.05, I guess in this case again. So your critical value is 0.754. So 0.754, so I'm going to draw a little line here, shade, positive 0.754 and negative 0.754 and shade to the outside. So I'm going to, you know what? We're going to skip ahead a bit. Hold on a second. I want to talk about the second part that we didn't really discuss. If I get this to work. Regression. Great. So that line we found a second ago, the y equals a plus bx, that is our regression line. It's a line of best fit. In other words, if we took every single point and figured out how far it was up and down to that line and squared all those distances and added them, the line that gives us the smallest sum, right, because it could be any one of these lines. There's billions of lines you can draw through this thing. the one that gives us the smallest sum is our linear regression line of best fit. So we use that regression line to predict values of, values of y for a given x, only when there's a relationship. So I can only do this when x and y are related. In other words, when their correlation is close to 1 or negative 1. In other words, when I rejected h naught. So if I reject h naught, then I can use that. When r is not significantly different from 0, let me pull up that slide. That might make things a little bit easier for you. Go. Then, if we do not reject h naught, right? So then the r is not significantly different from 0, just due to randomness. Then just use the average y. Now let's use y bar. So this top one is when we're going to use y equals a plus bx. And this bottom one is when we're going to use y equals y bar, the average y, to predict. So this is the thing where people get stuck a lot, and this will cost you about, it's probably worth about 8 or 9 points on the exam. Those are 200-point exams, so it's probably worth 4 or 5% of your final. Okay. And then how do I find this? Y equals a plus bx. Use your calculator and the linear t-test. That gives you your a and your b. Couple comments. You should only use it if your data is sort of kind of within reason. Like I might use data from the last 20 years to predict what might happen in the next 10 years, but I can't use the data for the last 20 years to predict something that's going to happen 50 or 60 years in the future. That's beyond kind of the stretch of that, because so many things could happen in that time. So kind of, if your data only goes from like 2000 to 2020, then you really shouldn't go much beyond like 2030 maybe. But if your data goes from like 1800 to now, 200 years of data, then you can go another 100 or 200 years in the future. That kind of, that makes a lot more sense. And also if your data is not correlated, in other words, if r is close to 0, so there's no relationship, right, you do not reject h naught, then you just use the sample mean. You can't use that line. Right, so this is, for example, here's a couple samples there, totally not. So here's a sample up above. Do you guys see that? So these are clearly not correlated, right? There's just a bunch of random dots. Everybody kind of see that? And it will give me a correlation. It will give me a linear regression line right here. And then, if I think I just changed one number, 1 point here, and I got a totally different line. It's going in a different direction. So here, this line, if you went along it, you'd end up with way out here. Whereas this line, you'd end up way down here with this one, just from like removing one small point, 1 point. So these lines are kind of subject to really giving you the wrong answers, right? Because your data is not aligned. You should not use these lines. You should use the red line, the average. The correlation line, this black line through here, the linear regression line, don't go using that when your data is not aligned. When your data is just a bunch of random dots, just use y bar, the average. Make sense? So like say this is test scores. Test scores compared to their heights. And obviously people who are taller get higher test scores up here. But over here, I just removed one person who was short and had a low test score, and all of a sudden now if you're tall, you tend to have a little bit lower test score, right? That doesn't make any sense. So why? Because height and test scores are not correlated. So you just use if I want to predict someone's test score, I would just take the average score. That makes a lot more sense. Here's an interesting quandary. So all 4 of these you can see that this top left one here and the bottom left one, they sort of are kind of line-like, more or less. But all four of these have the same R, and the same, I believe they all have the same, and they have the same linear regression line as well, the same y equals a plus bx. And you can see some of them totally don't make sense. So that's why it's good to graph it as well. You can kind of see if it is like a line or if it's totally not like a line. If it's something weird, we have some outlier and something else going on. This is unusual, but that's what makes it interesting. All right, so you guys finish up your quiz problem 2 if you didn't, and do lab problem 6. I'll give you guys 10 minutes in your rooms. So first, let's take a look at this. Fires. Yes, go ahead. Yes.
There's one response to that problem. It asks about the predicted value also, the p-value.
Oh, I am not going to worry about that. I'm not going to worry about the p-value for this one. That's okay.
But we can just
Yeah, totally. Yeah, I think it's great to write that down. So what did you get for the p-value?
It's 5.1409.
That can't be. So it must be E something. E negative 2? Right.
0514.
Thank you so much. So give that to me again. You said 5 point what?
5.1409. It's -6. E -6.
Right. So that's a great point. So
-6.
yeah, -6.
Yeah.
So what you should notice is your p-value it's a probability, so it should be between 0 and 1. Anytime you get a probability more than 1, then you darn well better have an E negative something after it. That means you put 6 zeros. That would mean I'm going to do 6 zeros, and the period goes after the first 0. So 1, 2, 3, 4. I need one more 0. 1, 2, 3, 4, 5, 6 zeros, and put the point decimal place after the first 0. So that is much different than that, right? Than 5. I mean, these are the same thing, but this is much different than 5%, 500%.
Right.
Thanks for pointing that out. All right, great. So I'm going to give you guys. Do you guys think is 10 minutes enough, or is that not enough to do